All right, this is video 2 of our Jedi lessons for week 3. Our question is a 1,300 kilogram car. So we're just going to draw a little car here. All right, our little car is moving east. So we're driving east with an initial speed of 28.2 miles per second. Meters per second, sorry. 28.2 meters per second. The car is slowed down, or after 11.4 seconds, the car is slowed down to 11.9 meters per second. Find the magnitude of the net force that produces the deceleration. So he's going for 11.4 seconds. And then he slows down our little car. I don't know what vehicle I'm making now. Whatever. I lost track. Sorry. 11.9 meters per second. Wow, my car. Okay, that's fine. So what we have is let's use a different pen. We have a 1,300 kilogram car. So that is the mass of the car. And the mass measures the amount of matter in an object and its resistance to acceleration. We use this for our SI units, this is in kilograms. For our equation today, we are going to be doing, so we're going to be doing, we have V1, V2, distance, time. We are going to be doing V2 equals V1 plus acceleration in time. For our list, for our laundry list, our initial velocity, so our V1, 28 equals 28.2 meters per second. For our second velocity, we're going to be doing 11.9 meters per second. For our acceleration, that is unknown. We are trying to figure that out because we're trying to figure out the deceleration of this vehicle. Distance, we can get rid of it because we're not going to be using that equation. And then our time, it took us 11.4 seconds. So we can just get that. And then 11.4 seconds. In order to get what we need to get our acceleration to be alone, we are going to, first we're going to move this over, V1, so we're going to go over here, so then that'll be AT equals V2 minus V1, but in order to get our acceleration alone, we have to divide both sides by t. When we divide both sides by t, we will then have A equals V2 minus V1 over our time. So, to figure that out, we are going to plug in our numbers from up here in our laundry list down into here. So A equals 11.9 meters per second minus 28.2 meters per second over 11.4 seconds. That is going to come out to 11.9 minus 28.2 negative 16.3 meters per second over 11.4 seconds. If we divide by 11.4, we get negative 1.429824, blah, 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 blah. A whole lot of extra numbers after that. Now, we are trying to find the net force find the magnitude of the net force that produces the deceleration. So, what we are going to do is we are going to use force, because now we have our acceleration. So we have our acceleration right here. Now we are going to do force equals mass times acceleration. And the mass of our vehicle is 1,300 kilograms. So we're going to plug that in, 13 kg times our acceleration. And I'm just going to simplify this down to a smaller number. So we're going to do negative 1.4298, just to make it a little simpler. We're going to multiply those together. So 1.4298 times 1,300 is negative 1858.74. But since we are trying to find our net force, this needs to be a positive number. So we are just going to put that in. So our net force equals 1,859 newtons. And that is the force needed for the deceleration of this vehicle.